Welcome to This Explainer. Today, we're going to break down the SkyAssist AI capstone project and explore exactly how it transitions from a streamlined front-end MVP today to a fully realized enterprise-grade application tomorrow. So whether you're a capstone reviewer, an instructor, or a non-specialist technical stakeholder, my goal is to give you a clear, honest, and realistic look at what this project actually does right now and where it's headed.
Okay, let's dive right in. I want you to put yourself in the shoes of an airline customer service representative for a second. Imagine a passenger is standing right in front of you at the counter, or they're waiting on a live chat, and they need to know instantly if they can bring a specific item on board. How fast can you find the official dangerous goods policy? Normally, it involves a lot of frantic keyword guessing while the passenger is impatiently tapping their foot.
Here is our roadmap for today. We'll quickly cover the policy search problem, walk through a SkyAssist user demo, look at how retrieval works, break down the architecture and deployment flow, go over our current MVP limitations, and wrap up with the future enterprise roadmap.
So starting with part 1, the policy search problem.
The biggest hurdle right now is that information is completely scattered. Airline reps lose so much valuable time digging through disconnected documents. Whether they're looking at baggage allowances, refund rules, or international travel requirements, this scattered data creates a massive need for a fast natural language search tool. Manual searches aren't just frustrating for the reps, they lead to inconsistent responses for passengers, and that absolutely tanks customer satisfaction and operational efficiency.
Moving on to part 2, the SkyAssist user demo.
In our current Angular MVP, the workflow is incredibly smooth. Instead of opening a dozen different PDFs or internet pages, a user just performs a simulated login to the dashboard. From there, they ask a realistic question in plain English, maybe something about ticketing rules. The interface instantly fires back the best matching answer, complete with a verifiable citation. And finally, the user can submit helpful or not helpful feedback right there in the chat, which gets stored locally in the browser to keep track of the session history.
The crucial takeaway here is our intense focus on traceability. Look, in a heavily regulated industry like aviation, you simply can't guess an answer. The representative can instantly preview the source document to verify the response before passing it along to a passenger. It builds immediate trust in the tool, which is exactly what we want.
Which brings us to part 3, how retrieval actually works under the hood. Let's skip the heavy math for a second. We use TF-IDF, which stands for Term Frequency Inverse Document Frequency. Basically, it acts as a highly effective keyword similarity and matching tool. When a user asks a question, the application compares that query against our local JSON policy dataset. TF-IDF looks for words that are highly relevant to the specific question, but may be less common across the entire rulebook, and it uses that to score and rank the best possible policy entry.
Now, I want to be radically transparent with our technical reviewers here. While this setup demonstrates intelligent, AI-inspired retrieval, the current MVP explicitly does not use Azure OpenAI or any kind of generative AI to invent new answers. It strictly retrieves existing pre-written policies. That distinction is super important for understanding exactly what this proof of concept proves today.
Next up, part 4, architecture and deployment flow.
In our current Angular architecture, you'll notice a very intentional separation of concerns. The user interface code, like the dashboard and chat, stays distinctly separated from the TypeScript search logic, the local JSON data assets, and the browser's local storage. This was a core lesson we learned during development. It makes the application highly maintainable, ensuring that if we update the policy content, we don't have to completely rewrite the search logic.
For deployment, we've set up a fully automated continuous integration pipeline from GitHub to Vercel. It's incredibly straightforward. Anytime a verified code change is pushed to the main branch in GitHub, Vercel instantly detects it. It installs dependencies, generates the optimized Angular files, and securely publishes the app over HTTPS. It's a modern, low-friction way to get updates out to users with almost zero manual effort.
During the coding process, we used GitHub Copilot for troubleshooting and code generation. It was a fantastic tool for explaining unfamiliar concepts, but it really drove home a vital lesson. The human developer is still entirely responsible for solution design, validation, and architectural ownership. Put simply, AI accelerates the typing, but definitely not the thinking.
Let's talk about boundaries in part 5, current MVP limitations.
It's important to remember that this MVP is exactly that, a minimum viable product. It's a capability demonstration. Right now, it relies on a local dataset, meaning really complex or ambiguous questions might not find the perfect match. The login is simulated. It's not tied to a real enterprise identity provider yet,
And because we don't have a central database or document ingestion pipeline, your history only lives in your current browser session. So it absolutely should not be treated as an authoritative production system just yet.
And finally, Part 6, the Future Enterprise Roadmap.
We are actively planning our move away from this local, simulated reality and towards a much more intelligent future. The goal is to evolve from a standalone browser app into a robust platform powered by governed enterprise services, centralized data, and most importantly, grounded generation.
Here is exactly what that future looks like technically. We're going to establish a backend foundation using Spring Boot APIs and a Postgres database so we can centralize history and feedback. We'll swap out that simulated login from Microsoft Intra ID to guarantee secure, role-based access. And the biggest leap of all? Replacing our local TF-IDF matching with Azure AI Search and Azure OpenAI using Retrieval Augmented Generation or RAG. That means future answers will be dynamically generated for a natural conversational flow, but they will remain strictly grounded to approved, secure policy sources.
What SkyAssist does today is successfully demonstrate an end-to-end product journey. It identifies a massive service problem for airlines, proves we can solve it with a maintainable Angular interface, and provides stakeholders with a totally honest, realistic path toward a scalable AI platform.
As we wrap up this explainer, I want to leave you with this thought. If we can successfully bridge the gap between frustrating, manual document searches and enterprise-grade source-aware AI, the speed and accuracy of passenger support globally will be completely revolutionized. Just imagine how much frustration could be erased from the travel experience when every single agent has the exact right answer at the exact right time, backed by rock-solid proof. Thank you so much for exploring the SkyAssist project with me.